Hello everyone, welcome to this presentation on image classification explained. A simple guide. Today we will break down what image classification is, how it works and why it's such an important technology in our world today. Let's dive in. So what exactly is image classification? In simple terms, image classification is the process of teaching computer to categorize images into different classes or labels based on their content. For example, if you show a computer a picture of a cat, it should be able to label it as a cat. This is foundation of many advanced technologies we use today. Now, why is image classification so important? Well, it helps computers understand and interpret visual data, just like humans do. This capability powers applications like facial recognition, medical imaging to detect diseases, and even self-driving cars that need to recognize traffic signs and pedestrians. Without image classification, these technologies wouldn't be possible. Let's talk about how image classification works. It's a three-step process. First, input an image into the system. Second, extract feature from the image like edges, shapes or texture. Finally, a machine learning model predict the class or label for the image. For example, it might look at the feature of an image and decide it's a dog. Simple, right? There are different type of image classifications depending on the task. Number one, obviously the binary classification. This involves two classes like cat or dog, or for this example it is dog or not dog. Then number two, multi-class classification. Here there are more than two classes. Like identifying different type of animals. For example, we can identify dog, cat, even other animal, but for this example it has also bus, plant and so on. Then the third one is multi-level classification. In this case, an image can have multiple labels. For example, a picture of a beach might be labeled as sun, sand, and ocean. And for this example, you see in this multi-class, we have a dog and a plant. So when we give this image to the classification model, it gives us two labels. One, it sees dog in this picture, and the second one, it sees plant in this picture. So these are the main three types of image classification. To perform image classification, we need machine learning models. Some of the most common models include convolutional neural network. CNN are the backbone of image classification. These use convolutional layers to detect patterns in images, making them highly efficient for tasks like recognizing objects, animals or faces. Popular architecture of CNNs are ResNet, residual network, VGGNet, and MobileNet are some example. So MobileNet is optimized for mobile or edge devices. The second type of most commonly used image classification models is vision transformers. Unlike CNN, vision transformer use self-attention mechanism from transformer to analyze images. They divide images into patches and process them similar to the words in natural language processing. Vision transformers have outperformed CNN in some cases, especially in large dataset. Then there is another example, which is efficient net, a family of CNN architecture designed to balance accuracy and efficiency. Efficient net scale network depth, width, and resolution together, making it highly performant with fewer parameters. So those are the three most commonly used image classification models. Let's take a close look at convolutional neural network, or CNN. These are the go-to method for image classification. CNNs are special layers like convolutional layer to detect patterns, pooling layer to reduce complexity, and a fully connected layer to make final prediction. Think of CNN as a super smart system that learns to recognize images step by step. So this part, including the convolutional and pooling layer, this part extract feature from the input image, and the fully connected layer is considered as a classification part of this network. Now, how we train an image classification model? Here is the process. First, we collect and label a dataset. For example, we gather thousands of images of cats and dogs and label them correctly. Next, we split the data into a training set and a testing set. Then we train the model using the training data so it learns to recognize patterns. Finally, we evaluate the model using the testing data to see how well it performs. This ensures the model can generate to new and unseen images. Image classification has countless real-world applications. Here are just a few. In medical imaging, it detects diseases like cancer from X-rays or MRIs. In autonomous vehicles, it used to recognize traffic sign, pedestrian, and other vehicle. In security, it powers facial recognition system. And in retail, it helps categorize product automatically. These possibilities are endless. To wrap up, image classification is a powerful tool that enables machines to understand and interpret visual data. From healthcare to self-driving cars, its applications are transforming industries and improving our lives. Thanks for watching, and I hope this presentation helped you understand the basic of image classification. If you have any question, feel free to ask in the comments. Thank you.